Next question we had was on 2260. 2260 says that we have this aromatic that's going to react in the presence of dichloromethane and aluminum trichloride. When we do that, we result in something that has an NMR spectrum. The carbon NMR has 4 aromatic peaks. We have the deuterated chloroform peaks around 77, so we can ignore those. That's solvent peaks from running the NMR. And then we have 1 benzyl peak that we see as well. If we look at the proton NMR, we also see a benzyl peak, which makes sense. We could interpret it differently, but since we already know there's a benzyl from the carbon-13 spectrum, and we have a pretty good idea that there's going to be some sort of attachment between this and this, we assume that it is a benzyl peak. That benzyl peak has an integration that's shown that is about 1/5 of the aromatic integration. So we should see 5 times as many aromatic peaks as we see benzyl peaks. Probably we're going to install both of these hydrogens, so that would mean 10 aromatics. If we substitute once on this group, we'll have 5 other protons that are aromatic. We have to substitute twice on here, once with each of the chlorines, to get the product that we would expect. We would end up substituting the first time and ending up with a CH2Cl. We can further react with aluminum trichloride that is present in order to add on another benzene on the other side, and now we have a biphenyl type molecule. This biphenyl molecule will have 5 aromatic hydrogens over here and 5 over here for a total of 10, and 2 benzyl hydrogens, so we'd have 5 times as many aromatic hydrogens as we had benzyl hydrogens, which matches this. It also gives an IR spectrum for this, but the IR is not particularly interesting because we don't really see a lot of detail to this spectrum. It's mostly aromatic CHs and just normal CHs.